and welcome to my talk at the Cosmos DB Conf 2022. My name is Thomas and I'm working for Matema as CTO in Germany. Today I'm going to present you some ideas how to use and enhance Gremlin.NET with Cosmos DB for code analysis. But before jumping right to the agenda of the next 25 minutes, a word of caution from my side. This is work in progress. So things I'm going to show here are not yet fully completed. We are currently working heavily on this. At the moment, we are especially looking in how to improve the implementation of the .NET backend with Cosmos DB using Gremlin.NET. So today I'm going to concentrate much more on Gremlin.NET rather than on the code analysis part and how to utilize graph databases for code analysis. So coming to my agenda, I'm going to give you a brief personal motivation why I'm interested in graph databases and Gremlin.NET. Second, I'm going to explain how I model code as a graph. And then I'm going to use Gremlin.NET and show to you some examples how to use it and how to extend it as well. And finally, I'm going to give a brief wrap up of the whole thing I'm going to show you in this 25 minutes. Okay, my personal motivation is this tool. So I have implemented a code analysis tool using Microsoft technologies to show code with the so-called city metaphor. So in this city metaphor, code is shown as buildings, and the size of the buildings depend on various metrics you can measure on code, like code size, cyclomatic complexity, or things like coupling to other classes or number of methods. All this stuff you can measure with typical static code analysis. And this tool is going to present it in a 3D code model, which you can then move into. But this tool is lacking a couple of features like persistence. There is no query capabilities, so I can't do some ad hoc queries. I don't have any possibility to extend my meta model right now, but I would like to do so. For example, I would like to add some more information about Git access to the code. And I don't have a web UI, so there are no web capabilities right now. It's a sole rich client application. But today, I'm going to concentrate much more on the persistence and query capabilities. So when I looked into this, I was wondering, okay, what kind of persistence I could use. And for connected data like such code models, it is a perfect thing to use graph databases to persist such code models. Here I have shown you 3 different examples how graph databases are going to query data like connected things like my code model. As you can see, there is no standard as we have in SQL for relational databases. One example, OrientDB, they have a SQL-like query language. The other example, Neo4j, which is one of the most famous graph databases using Cypher, a proprietary language. And the third example I've given here is the Graph Engine, which is a research graph database implemented by Microsoft. They are using an IDL-like language, which is compiled into .NET code so that later on LINQ can be used to query objects. But all these languages are very, very different from each other. So this was not the goal or the language I would wanted to use. So I looked further and found another solution called Gremlin. Gremlin is a language which is provided by the Apache TinkerPop project. And this language is supported by various graph databases like Cosmos DB. Some do not support it, like the Graph Engine, but that was not of a major issue for me because I could use Cosmos DB and some other graph databases using Gremlin. And some databases, like Cosmos DB, directly even support Gremlin. Others do not, so you have to use some intermediate server to transform Gremlin into the proprietary language, like for Neo4j. Okay, before we really jump into Gremlin, I will give you some terminology which is usually used in graph databases. So we usually have a so-called property graph, and that is also supported by Cosmos DB. In a property graph, we have vertex and vertices, like the three ones shown here in this example. So Thomas is a vertex, the Cosmos DB is a vertex, and Max is as well a vertex. Vertex can have labels like person, conference, person. So this is a kind of a type declaration. And those vertices are connected using edges, as shown here. Edges can have direction, but don't have to have. Besides these three artifacts, properties can also be part of a vertex or even an edge. So that's why we are talking about a property graph, because we can have key value pairs attached to the vertices as well as to the edges. Okay, so if we have this in mind, we can also take a look at code as a graph. So if we take this small snippet, and this is how I do it in my tool. We have a code model, and inside this code model, we have a namespace vertex, and this does have a second attached or child vertex, once again a namespace, which is called code model to graph. And inside this namespace, we will find a vertex of a class called demo, and that is derived from another class. And that class, the demo class, is having a method called say hello. And inside this method, we are calling another method, WriteLine, from another class, namely console, which is part of the system namespace. So as you can see, a graph can be easily being used to model the code which we have seen in this small snippet. But if we have this model, how do we bring that into a graph database? As I mentioned before, we can take a look at Gremlin, Gremlin as query language to persist and to query our code model into Cosmos DB. As mentioned, Cosmos DB is supporting Gremlin out of the box. Therefore, we have to use a library which we can install using NuGet, GremlinNET. So there are other implementations for Java, Python, and all major languages usually being used in enterprise applications. For .NET, we have GremlinNET. There have been previous libraries like Tiva, but that is the standard library for the time being. Currently, if we are really using Cosmos DB, we have to keep two things in mind. Cosmos DB is supporting GremlinNET 3.5, but not the current version 3.6, which was released only a couple of days ago. And if we are using Cosmos DB, we cannot use graphs and 3.0, which is the transport format of the data which is sent to a graph database using Gremlin, but we have to use the old version 2.0. That is important to keep in mind. Okay, so now if we are going to want to create a connection to Cosmos DB, we have to create a Gremlin server object, and the data like the host name, the port number, we can retrieve from the Azure Cosmos DB portal, either by going to the quick start examples or by retrieving the data from the portal itself. It's important that all connections to Cosmos DB are encrypted, so we always have to enable SQL, as you can see here in this example. And the username is a little bit different to other graph databases, so we have to add some more details which are specific to Cosmos DB, like the DBS and the collections. And the password is the Cosmos authentication key, which you can set inside the portal itself. Yeah. If we have created the Gremlin server, then we can create the Gremlin client, which is then being used to submit the queries to the database. Yeah. And as you can see, as I have already told you, we have to use GraphSim2, reader and writers, and we have to use the specific MIME type for this as well. So that is the most simple case to connect to Cosmos DB. We can also, as shown here in this example, have some more configuration on the connection pool settings if we would like to. But more or less, this example is the same as we have seen before. So the Gremlin server is the same, but the client here has a little bit more configuration configured. But that is not of such an importance for this talk here. Okay, now that we have created the connection, let's go and issue some requests to the Cosmos DB itself. And this example has been taken more or less from the quick start guide or quick start example from Cosmos DB. We have the Gremlin client as explained before. And now here comes in the next line, the important thing to submit the query. And here you can see already something which I will talk a little bit more later. Here I'm going to send the request. So this one is giving the commands to the Cosmos DB or to the graph database. And the result I receive is something untyped, and I have to look into these result objects by myself, have to deserialize, so to say, the objects, and then have to work on that. Okay, and to be honest, this kind of approach, it's not that nice. It has some drawbacks, serious drawbacks. First, we have to create our request as a string. So if I do something wrong, it will hit the database, and only there it will tell me, okay, what you have written here is not a correct Gremlin command. You have to repeat it, so to say. That's the first thing. The second thing is the result is, as I mentioned, it's untyped. So I have to take care myself to deserialize it or serialize it into the correct objects afterwards. And that is something I don't really want to have, and that the TinkerPop project as well does not recommend anymore. So these script-based requests are replaced now by the so-called bytecode-based approach. The bad news here is Cosmos DB does not out of the box support bytecode-based requests, but there are some mitigation options as well. So one is using the so-called GremlinNET Extensions, which is a NuGet package you can download. But as you can also see, the last update is almost 2 years back, so it's quite old. Okay, if it's mature, then it's okay, but there's some drawbacks as well in this approach. And I'm going to show it in one example here, how it looks like if we're using these extensions. So the good part about it is now we can start really to formulate our queries with the bytecode based request approach. So instead of using the Gremlin client directly, we are going to create an anonymous traversal source, like shown here, create a traversal, and then using this traversal, we add the things we would like to do. So in this example, I'm going to add a new vertex, having the person label and adding two properties, first name and another one being called hobby. And then instead of calling the normal bytecode based terminal steps like next or to list, we are using a specific one of this extension called toGremlin query. And this one is creating an object which contains the query itself as a string, which we can use later on, as shown here. And it also contains the mapping of these properties to the values itself in this dictionary, which we can use as arguments later in this second call. But with that approach, we have now a bytecode-based request, but the result is the same as we have in the original script-based approach. So we are only half done, so to say. So the question was, okay, what now? Shall I stick to this approach or should I do something more complete in a bytecode-based sense? And that was exactly the idea I had. Okay, I will create a solution which really fully supports the bytecode-based approach for Cosmos DB. And this is how I implemented that. So first, an example how the bytecode-based approach should look like. So in this example, I'm creating a new edge between two nodes or vertices, which represent classes. So I have a full qualified name. So I have one class which I'm querying, and I add a new edge between this one and this one. And I just wanted to show here an example how to create an inherits from a relationship. And as you can see now, I have here the next, which is the terminal step to really fire off the query to the Cosmos DB. And instead of using Gremlin client, as you can see, I'm really using this graph traversal source as we had in the previous example. But how do I get to this graph traversal source? So normally I do the following. I'm having the Gremlin client. Using the Gremlin client, I create a driver remote connection, and then I create a traversal to a remote database using this driver remote connection instance. That is how I would do it normally. This can't be done with Cosmos DB, so I created my own implementation of this driver remote connection called Cosmos DB remote connection. And that one is implementing the iRemote connection interface, which is shown here. So this is the iRemote connection interface is the entry point to send a request to a graph database. And usually it's sending bytecode-based requests to the graph database. And my to-dos have been, okay, instead of sending bytecode, I transform that one into a script-based request and later on deserialize the result into typed objects. And this is how the implementation currently looks like. So as you could see in the previous example, this is the method which is required by the interface. And in this line, you can see, okay, here we are sending really the request. And as you can see already, okay, that is bytecode. But how do I handle this bytecode? Okay, what I do is quite simple. So in Gremlin.NET, in the most current versions, 3.5 and 3.6, there's a so-called Groovy translator, which is able to create a string representation of the bytecode, which can be really sent to the Cosmos DB as a query. And the result I receive back, similar to what we have seen in the very first example of the script-based examples, I receive a result set, and now I try to deserialize this result. I have not shown an example how this deserialization currently looks like. You can see that in my GitHub repository. So currently, that is work in progress. I'm able to deserialize vertices, list of vertices, edges, list of edges, paths, as well as value maps. That is basically the things I need to do for my code analysis tool to persist the code model into Cosmos DB. Having created that, I implemented a small tool which is analyzing .NET assemblies, only standard .NET framework assemblies right now. And the data is then persisted into Cosmos DB. After I've run the tool, I could use, for example, Gremlin console, or at some later point in my .NET backend, queries to ask for certain things like what I have shown here. Here I'm going to ask, okay, give me all the classes which have more than 30 incoming accessed by edges. So I'm trying to find, okay, are there any classes which have too high coupling? In this case, only efferent coupling, so which is inward bound. And we also created some small tools to visualize that with our tool set, which is shown here. Here I'm using the voided method count to look into classes which are really, really complex, like this one, and which have a lot of dependencies. So all the black vertices you can see here are connected to the green vertex, which is really complex. And if I change that complex class, anything of its public members, it will affect all the black ones. So I know, okay, if I'm going to change the green one, I have a lot of things to do. So this is only very early stage of work in progress for these things. As I said before, we are currently heavily investigating, okay, how to improve the Gremlin.NET for Cosmos DB. So and that is already the end of what I wanted to show today. So Gremlin.NET is currently using script-based requests, which are not recommended anymore by TinkerPop. I've shown you some examples, okay, how we can extend Gremlin.NET. There's already one library existing since almost 2 years. We are currently creating our own one so that we can have kind of pure bytecode-based requests. And which was not shown, it's the third point here. It's grayed out a little bit because I have not shown it in the slide so far. We also extended Gremlin.NET a little bit because the data which is given back by Cosmos DB does contain a little bit more information which I would like to utilize in Gremlin.NET as well. So that's it from my small library which I have shown here. Some more resources you would like to probably take a look at: the documentation, our TinkerPop, the reference documentation, some more recipes where you can find some good solutions, a cheat sheet, and most remarkable, in my opinion, the Gremlin graph guide by Gavlin Lawrence. It's a really cool book. You should take a look into this. And last point, the little library we have written for bytecode for Cosmos DB. So that's it from my side. Thank you very much. I hope you enjoyed the last 25 minutes, and I hope you see some more cool talks at the Cosmos DB Con this year. Thank you very much.